EET 114, Chapter 18, Nodal Analysis. So, for independent sources, before examining the application of a method to AC networks, review the sections on nodal analysis in Chapter 8. So again, we're following the same procedure. So determine the number of nodes within a network. Step 2, pick a reference node and label each remaining node with a subscript value, voltage, V1, V2, and so on. The reference node is going to be ground. Step 3, apply Kirchhoff's current law at each node except the reference node, which is ground. Assume that all unknown currents leave the node for each application of Kirchhoff's currents law. Step 4, solve the resulting equations for the nodal voltages. With dependent current sources, for dependent current sources, the procedure is as follows. Steps 1 and 2 are the same. Step 3 is treat each dependent current source like an independent source. So it's really not any different. And then step 4 is as before. For independent voltage sources between assigned nodes, steps 1 and 2 are the same. Step 3 is modified. Treat each source between defined nodes as a short circuit. Okay, so you're going to short out this voltage source, and step 4 is as before. And for dependent voltage sources between defined nodes, it's probably going to say the same thing. Steps 1 and 2 are the same. Step 3 is essentially the same as that applied for independent voltage sources, except that now dependent sources have to be defined in terms of the chosen nodal voltages to ensure the final equations have only nodal voltages as their unknown quantities. So this is a voltage dependent voltage source here, which that would apply to.